Happy New Year. This is New Year's Day, 2026, and I just want to talk about where we are with climate change as we head into the new year and wrap up 25. And I got really good news because I claim, and I'm going to talk about it here in this video, that we're in complete agreement. There's no unsettled camp anymore because the U.S. Department of Energy, the Trump administration, has put down a threshold for which, if we exceeded, we would need immediate and aggressive action to take on climate change. So we agree on the fact that there's a threshold. I would agree on the threshold. So we agree that there is a threshold. The threshold was established by the Trump administration. And I agree with the threshold. Now, I also claim that just as a matter of fact, whether you this is just a mathematical analysis, we've exceeded the threshold. And we've exceeded the threshold on the basis of historical data. So really kind of 24, 25 were tipping points of when we exceeded the actual data to meeting and exceeding this threshold for immediate aggressive action. And I want to kind of walk through that claim and say that's a good thing because we certainly need to forge some consensus in the public mind on what we agree on. And I claim we agree on enough that there is a threshold. It's written down, established by the Trump administration. We exceed the threshold for immediate aggressive action. So let's focus on what we agree on. That doesn't mean everybody's a good guy, that they're not people spinning this issue on the part of one side or the other side. That happens. That there aren't people on either side of this issue that have agendas. They do. That we don't know everything we're ever going to know. No, we don't actually know everything we're going to know. But we know enough. And we know that we've met this threshold established by the Trump administration that we've now exceeded. So important in this argument to exceed this threshold were in fact the last 4 or 5 years, the last 10 years. So I don't really want to impugn the motives of the unsettled crowd. What I want to do to the unsettled crowd is point out the fact that they established the threshold and we are now in excess of that threshold. So, as an aside, I talk to people every day who are good people, smart people, well-educated people who don't know that A, there's a threshold that was established by the Trump administration, and B, that we've exceeded the threshold. So I would say that some of the people that are involved in the unsettled argument, that are professionals in this, they haven't really taken the time to analyze the last 5 years because they've established these positions a decade ago. So let's launch into this good news. The other piece of the good news is really fascinating. Like in my career, I kind of started off in the power industry in the birth of the gas turbine age, and that was my background as a gas turbine engineer. And I saw really the maturation of that technology through the full cycle. It was really amazing. And I'm seeing the same thing again in solar. And so it actually, new technologies do come along that do change the landscape of what goes on. And so it's not a bad thing. It's a good thing. And just like through the course of this gas turbine evolution, we were fighting every step of the way the incumbency, and the same things happen all over again in solar. And so I'm not terribly surprised. What I am surprised is how successful it is to address this climate change issue because the killer applications to the tools to address the circumstance have evolved to the point where they're cost effective. So when I say there's climate change, we need immediate aggressive action. What I'm saying is if we take immediate aggressive action, we're actually going to decrease the cost of producing energy to the economy. And we're seeing that here in the United States and all over the world. Here in the United States, kind of fun fact is we had 2020 2025, more than 40% of the power for half of the United States, 40% of the power, half the United States is wind and solar batteries. So, okay, let me launch into my pitch on why we've exceeded the threshold. And I'm going to share my screen. Boom. So if you believe in this blue line right here, if you say to yourself, well, that blue line very accurately describes all those dots, we're done. This matter is settled. And clearly, the blue line does accurately describe all those dots. So, what are all those dots? Those dots, and just as the kind of another background, I deal with math every day. And so, as someone who deals with math every day, you just naturally assume other people, even other smart people, well-educated people, are comfortable talking about math. In fact, I find the opposite's true. Most people that don't deal with math every day aren't comfortable talking about math at all. So I'm not really trying to talk down to people when I go try to distill this into something very basic and understandable. But what those dots are representative of the 10-year moving average of the temperature change of the globe. And I'll go into kind of some more nuances around that in a little bit. But that curve, the blue curved line that goes right through all the dots, that fits, in math speak, the dots. It describes the dots. It's representative of the dots to a degree of 0.95, and one being perfect. So that blue line nearly perfectly describes those series of dots. And what each of those dots are the 10-year average of the previous 10 years global temperature. And I will say, just to not trying to hide hide any of the data, I present the full data set down here a little later, and that's all the data. So that's not the 10-year average of the data, that's just every year's data. And sure enough, there's a line and it looks just like the other line. And it's the blue line, and it fits those dots to 0.91. Both 0.91 and 0.95 are excellent fits, if you will, for describing the data set. So a couple of points, just looking at the data. This is the data set from 1880 to the end of 2025. A couple observations. The dots are going up. So this shouldn't be a big surprise. It's the 1st of the January, and I'm here in New York City, and I walk from one place to the other, and I put a scarf on. I didn't even put an overcoat on. So it's cold here in New York today, but it's not. It's January 1st. And it's really not that cold. And yesterday I didn't even put a scarf on. So people should realize that these dots kind of should fit their personal experience, because we all live the temperature, we're all outside. So I'm going to kind of dive on. Now, I want to point out that this is as hot as it's been in over 100,000 years. So this is the band of the last 100,000 years. And this is where we are right now. We're more than the band of the last 100,000 years. Now, this could be controversial. This is what would happen for natural variation. And this is what happens, the piece of the change that's due to humans. I really don't like to talk about computer models and what causes what or whatever. I'm just looking at the numbers, the historical numbers. Yeah, I think we're past the point where we need to talk about science. People like talking about science less than they like talking about math. I'd rather talk to someone about religion than I'd rather talk about gun control, frankly, than talk about math or science. So people just have no interest in talking about math or science. So here we go. We don't need to talk about science. We don't need to talk about a model of the future. The Department of Energy, the Trump administration's Department of Energy has done us the favor of establishing a threshold. What I'm saying, and it is just a matter of a pen and a piece of paper, that this blue curve exceeds that threshold. So therefore, immediate and aggressive action is indicated. I'm also just trying to put this in context. Is this really hot? No, no, it's really hot. It's more hot than it's been in 100,000 years. Now, by the way, 100,000 years ago, we didn't have a billion people that lived on the earth, and we didn't have a very complicated global interconnected economy. So can the economy, can the current economy survive more of this heating and the impacts of this climate change? Apparently not. Otherwise, the Department of Energy wouldn't have said if it meets this threshold, we need immediate aggressive action. And I contend that we could make that argument 100 different ways. We want to talk about what we agree with. I don't want to talk about what we don't agree with. That's like the opposite thing of what we should talk about. Where did the Department of Energy say this? Well, they issued its draft report in July of 2025, a critical review of the impacts of greenhouse gas emission of the U.S. climate. And sure enough, in section 4.1, it talks about immediate aggressive emission controls becoming imperative if this threshold was met. It's met. Now, if you're sitting here 15 years ago, I couldn't say that. If I was sitting here 10 years ago, maybe I could start to say that. If I was sitting here 5 years ago, I could probably say it, but couldn't really nail it. I'm sitting here at the end of 2025, it's obvious, right? So sure enough, that blue line has an equation. I really don't like to talk about math. I already said that 3 or 4 times, but this is the equation that it does have. And so if you say to yourself, okay, Mr. Equation, that looks accurate. How fast am I growing? What is the rate of change? What is the speed of which I'm growing in 2025? And the answer to that question is high school math. It's 0.387 degrees Celsius per decade. Let's just call that 0.4 for the sake of argument. Now, this number is necessary. I mean, I calculated at the point of 2025, so that's good. But it's necessarily backward looking because it has these moving averages that are 10 years old. If you just said what's the average of the last 10 years of the moving averages, so that's data that's 20 years old. The answer is 0.3. Now, if I were to say, okay, math, not computer model of the future, not the climate model, not anything, but just plain old, what does the equation say that rate of change is going to be in 10 years in the future? And the answer is 0.524 degrees Celsius per decade. And if I go into mathematical toolboxes and computer software, Python, I use MATLAB. You could use Julia. Like it doesn't really matter what pick your poison R, and say, okay, here's the equation, and what's it going to be in 10 years? And the answer is 0.51. So it shouldn't be a complete surprise, right? Because I'm looking at this curve and this curve. So if I were to say, what is the average just not of the curve, but over the whole data set? Well, you get 0.02. So this here is 0.02. The average of the last 20 years, 0.03. This point right here is 0.04. On a forward-looking basis, we're at 0.05. So any of those numbers, 0.3, 0.4, 0.5, they're all a lot more than 0.2. In fact, by and large, let's just call them twice as much. So if the rate of change of the climate was changing at a rate that's 2 times more than the whole period record, have we exceeded this Department of Energy threshold? And the answer is absolutely. Yes. Like now, I'm just going to go try to wander through some more minutia here. Here's the data. Here's the straight line. So here's asking the computer, "Hey, make a straight line." Like, don't figure out what curve fits the best. Just go make me a straight line. Well, that's this line right here, and obviously, and those are the 95% confidence ranges. Like, we're off into 1 in 1,000 on the over the long term average. So the probability of being way up there is probably 1 in 1,000. In fact, I can tell you because I did the calculations, 1 in 1,000. And some of these other numbers are 1 in 100, and some of them are 5 in 100, and et cetera, et cetera. The joint probability that we've seen each of these last 10 years at 1 in 1,000, 2 in 1,000, 1 in 100, 2 in 100, the joint probability of seeing those outcomes year after year after year, the probability of that happening is over 1 in 1 trillion. In the math department, they'd call that almost surely zero. In the time scale of humans, it's zero. So no, this is not natural variation. It's not the weather. It's not, oh, it was, sometime the earth was hotter than it is. Yeah, but not when there are any people here. Not when there was any ice on the North Pole. Not when New York City wasn't underwater. So I just think we really need to stick with the Department of Energy's threshold, because we don't really need to go argue much more than that. Now, I don't actually hear from scientists but I do hear from people. Well, must be the data. I use the NASA data set. Now, the NASA data set was put together during Republican administrations and Democratic administrations, and Congress has been Republican and it's been Democrat. Like, the data is just the data. NASA put the data together. They wrote a paper, research paper, on how they calculate data. They published the research paper in a journal, and it's the methodology is available for anybody to poke holes in. If you don't agree with the technology, like, respond. There's no response. So, like, this data has not been professionally responded to because the professionals know that it's just fine. And there's other data sets. So let's go look at the other data sets. So here's this figure here is a figure of the other data sets. And no, it doesn't make any difference. Pick the NASA data set, the NOAA data set, the Berkeley Earth data set, the Chinese data set, the Russian data set, the UK Met Office data set, the European data set. It doesn't matter. There's no material. If I took anybody's complaint on the data and I said, okay, I'll take your complaint, I'll change the data based on that. My numbers, these outcomes, the 0.3, the 0.4, the point wouldn't change at all. Zero. So no, not the data. I hear, oh, it was hot once, but it will go hot to cold, and isn't this kind of normal? Like, we have hot years or cold years? The answer is absolutely not. I mean, one, you can kind of see that here. That's what all those dots are above the average line. So no, we're not doing, numbers around just random distribution. That's what you're kind of seeing here in the early part of the data set, actually. And then the climate changed, and all that went to hell. I don't really like to talk about attribution, like why. Like, I can look at this data because I kind of pay attention to this, and I can say, well, during that period, this was going on in the globe, and that's why that was happening. And then we started burning coal, and then we started cleaning the coal up, and then we started doing this, and then we cleaned up the oil from the ships. And so there's really two drivers of this climate change. One is the CO2, that is how much carbon dioxide from burning fossil fuels that man is doing, that's putting in the air. A little bit of a side, we can tell the difference between man-made carbon dioxide and the carbon dioxide that's naturally occurring, because the man-made carbon dioxide was from the time of the dinosaurs, and it's carbon for the carbon dating. So we can date that carbon. We can go up in the air and say, well, oh, Mr. CO2 molecule, did you come from a lump of coal or a a bucket of Saudi Arabian oil? And we can tell because of how we can tell how old the carbon is, right? Because the carbon radioactively decays. I don't, no, there's no one even argues about that anymore. Um, I did a test just to like put a stake through the heart of this, just the weather and that's called something. It's called a random process, right? A Brownian motion, random distributions, standard normal curve, the bell curve. So I did a test of this data to see if it had anything to do with the bell curve, and no, it's like failed the test. Not only is the data not normal, it's I call the data abnormal. It's the opposite of normal. So it's not the weather. It's not going back at cold. This isn't just, oh, there's some 10 bad years and they're going to be 10, it's going to go. No, no, we're just on this exponentially growing uh, curve. And so what's exponential growth? Means that this period, the growth is this much, next period is that much, the next period is that much, on it, on it, on. Not the data. Now I want to talk about sanity check. Okay, Chuck, you've got the data. The data says that the temperature is growing exponentially, and that sounds kind of scary and kind of is scary. Um, you made the argument that the Department of Defense has established a threshold. Yeah, you just go look at section 4.1 of the report. It's like it's in writing. Um, but like, could you have any kind of corroboration of this? Like, is there any other kind of data points? I think the obvious one to talk about is another, in climate science, we like to confuse people. So the climate scientists are all indignant because 99% of them agree to this climate change thesis, and there's four or five of them that don't. The four or five of them that don't are all in their 70s, and one just died. Actually, it was in his late 80s. So now we're down from five to probably four. And the other four in their 60s and 70s. So they'll end up, dying eventually. And we'll just have 100%. But they don't do themselves any favors, these 99%, because they bicker amongst themselves and they talk in a language that clearly the American public can't connect to, because otherwise this issue would have gone away a long time ago. The clearest way to make a sanity check on this is to look at how bright, how bright and shiny the Earth is from space. So when the sun hits the Earth, the heat that needs to escape goes back into the space. All is well. We look pretty shiny. When the sun hits the Earth and the energy is trapped by the greenhouse blanket, it doesn't go back into space. So the Earth looks darker. It's less shiny. This all makes perfect sense. And we measure from the satellites how much energy is going back into space, how shiny does Earth look that year. It's very easy to measure because it's just something that measures how bright the Earth is. And in scientific speak, they call that the Earth's albedo. And sure enough, we look over this same period and the Earth's albedo is going down, 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 down. So there is actually kind of a sanity check to all this. So I'm going to wrap up and say that number one, we need to change this climate dialogue to not what we disagree with, not whether we like everybody, not whether are bad people involved on either side of the issue, and not whether we need to find out a lot more stuff. Because we do need to find out a lot about more stuff. There are bad people on both sides of the issue. And we don't know everything. We know enough. We know that this threshold been established. I can tell you it's a very reasonable threshold. We know the threshold is in writing. And we know that at 0.4 and 0.5, we exceed that threshold. So let's talk and focus on not calling people names. It's not very helpful. Please agree with me. You're an asshole. Well, why would you ever say that? Like, and I got to tell you, the people on both sides of this issue, there's many very well-intentioned people on both sides of this issue. Is zero in anybody's best interest to call anybody names, right? Except Al Gore, we like make fun of him all we want to. So, um, let's talk what we agree with, and let's try to forge some consensus on what everybody that puts a coat on and goes outside in the wintertime knows the Earth's getting hotter. And the other kind of piece of good news, like as this conversation becomes my model, says this to no, look at what's actually happened. It's much easier conversation to have because you don't really need to trust anybody. You don't need to trust their models. You just need to go realize that you didn't put your overcoat on the 1st of December in New York City. And you go back to that chart and say, well, geez, like, seems like the temperature is growing exponentially. And, I'm going to go to Chat GPT and figure out what that means. And, the outcome's pretty clear. We need to do something about this. And the other piece of the good message, so the message needs to change. And the animosity of the message needs to go away. It's like clearly a message of look at we have a problem, whether we thought we were going to have a problem or not doesn't really matter. What matters is it's obvious we got one. And the second piece of the message is the path forward is a bright path. These tools to deal with this climate change issue did not exist 15 years ago, certainly not 20 years ago. And so we are seeing the world, like just leave our own perspective of being in the US for a second, we are seeing the world change. The Chinese are putting in more solar every year than we have in America. They've put in our whole ever since the beginning. Um, the energy mix in the emerging markets. And Pakistan is a good example. Like in 2023, it was only like 2 years ago, they had like no solar. Now it's a third of their grid in 3 years. So we're seeing the rapid adoption of wind solar batteries. Why? Not because anybody wants to do anything about this blue line or climate change. Most people care less. But what they do want is cheap power. And the cheapest power just happens to be wind and solar. And I'll go into, mommy, where do we get power plants? It's going to be my next story. And I'm going to also talk about the just amazing strides we're making in energy poverty globally. Is kind of two separate issues. But that's what's next. And so I'm very optimistic because it really doesn't matter what political stripe you come from. It's pretty obvious. And I'd love to sit next to someone that took the other side of this issue because I don't know what they'd do. They certainly would have to talk about something else because they can't talk about the chart, right? So we're talking about, I don't know, like, weren't there two satellites that were missing one channel of data for 2 years? Like, doesn't matter, guys. But like these numbers are overwhelming and they're obvious. And I go to kindergarten. I'm going to ask the kindergartners, does that blue line fit those dots? And the answer is it does. It's like who won the boxing match? Well, the guy is not on the ground. So, I think that this issue becomes more and more obvious and more clear and more therefore addressable. And secondly, the cost to address this, we used to be, oh, we have to pay this extra money to go deal with. No, we don't have to pay extra money at all. It's actually cheaper to deal with this issue than it is to not deal with this issue because when we invest in cheaper energy sources, we ended up with cheaper power. Like the power is a big issue here in America because we're not building up power plants. That's going to be another video too. But very optimistic as we start 2026 on climate change, on energy and energy policy, because the outcome is being driven by people globally making individual solutions for themselves. And the outcome is just obvious on its face. Um, Thank you for listening.